All right, right. We left off yesterday talking about mirrors and the angle of incident versus the angle of reflection, and this idea of what an object is and what a image is. So we're going to start with a simple little simulation about that. So I hope this works. Yesterday I couldn't get it to, whoops, wrong button. If I go to here, all right, is the website that I just went to being shared with you now?
No,
Yes, it is. Okay, good. So
I don't see it.
you don't see it. Shit. Thought I had that problem solved, but clearly I don't. So let's do this. Let me stop sharing and then start to share it this way. Then I'll come back to sharing the PowerPoint later. Okay, now it should be there, right? You see?
Yep, I see it.
Beautiful, thank you. All right. All right, so, why his screen sharing has stopped as the shared window, something happened. Let's try again. There we go. Okay. How do lights reflect light? Reflect, right? How do light rays reflect? How do images form in flat mirrors, right? So let's just take a quick look at this. The idea again is the law of reflection is the angle of incident equals the angle of reflection, right? So the incident is the ray that's going into the mirror, and reflection is reflected off of the mirror, right? The normal is the perpendicular to the surface. So there's our incident ray. What happened? Come on. There's our reflected ray, and there's our normal line, right? So again, the idea is that the angle of incidence equals the angle of reflection. And remember, the angle of incident, and I hope, there it is. The angle of incident is between the normal and the ray. It's not between the mirror and the ray, right? It's this one. There it is, right? So they are equal to each other. So those are the things we're talking about. Okay, and again, we should see that they are, there you go. They're equal to each other, right? I think that's for a flat mirror. Oh, I can change my angle here. Do it again. Whatever, right? Change the angle, do it again. There, right? For a flat mirror, we're all kind of, that's pretty straightforward and simple, and we kind of have lots of experience looking at flat mirrors, right? What happens when we get to curved mirrors, and that's where things get a little bit screwy when we get to curved mirrors, which we'll do at some point. Hopefully, I'll at least have a chance to introduce curved mirrors a little bit today, at least. All right. Why am I trying it with a different mirror? There, whatever. Okay. I want to get out of that. Let me go. No. Can you make it? This is not right. We're all good with this. So I don't have to shoot the mirror, the laser all these times, right? Let's go to, where's the other half of the other half is this forming an image. Come on. There it is. Come on. It's gonna end up kicking, oh, no, it didn't. All right. So forming an image, right? Again, the object is the actual object, and the image is where and how it looks when it appears in the mirror, right? So there's the idea, right? Light travels in every direction, so it's going to hit the mirror going at different angles. We see things because they go into our eyes, and so on. All right, we'll talk about the lens in your eye when we get to lenses. But here is the idea of, right, angle of incident equals angle of reflection. So the light leaves, it bounces off of the mirror, and it goes to your eye. And then it goes there, yeah, okay. If we follow those, that reflection rays back, right? Following the reflection rays back along these dotted lines, you can see that they intersect behind the mirror. All right, and where they intersect, all those reflected rays behind the mirror intersect, that's where the image appears. Okay, so there you go. Okay, that's more, right? Different parts of the candle, of the flame, show different things. So here's our mirror, right? Here's our mirror, and it's going to show all of these angles, those incident rays going in all these different directions, and we will see, we pick out the top of the, right, from the top of the candle, the top of the candle appears here, the bottom of the candle appears there, right? The back of the candle, so on. Come on, why is it going so slow? There we go. And so on, now do a few more. And all right, so what does the candle, right? What does the image look like? All right, notice, it was kind of hard to notice, but the key idea here I want to, is that the image, right, is the reverse, right? When you hold your right hand up when you're looking in your mirror, it looks as the image of you is holding up the image's left hand, right? So everything gets reversed. So the candle looks like this, and this gray stripe is on the, away from the mirror. So that gray stripe is going to be away from the mirror here, right? So the image gets reversed compared to the object. Okay. Yeah. And then there it is, right? You can start to see like the gray stripe being away on the away side of the mirror. The shape of the flame is the opposite, and so on. Everything gets reversed in the image. Good? Anyone have any questions or comments about that? Flat mirrors are pretty straightforward. Okay. What am I doing here? Okay. It continues on. Why can I not delete the chat? There we go. To just do other images and so on. I'm not going to go through that process. I think we all understand that, right? That makes sense. We have plenty of experience looking in the mirror. Apparently, Sammy cries when he looks in the mirror.
Yeah.
That's a shame. I feel that's terrible that you have such a low self-image. I, on the other hand, love to look in the mirror because why wouldn't you if you look like me, right? Until the summer, and now then once I take my shirt off, then I don't want to look in the mirror. That's just embarrassing. Okay, let's continue on. let's go back to the PowerPoint. All right, how much time they got? Another 12 minutes or so. All right, continue on. Why am I not? Well, there we go. All right, so the angle, whoops. All right, mirrors, the angle of incidence, angle of reflection doesn't matter. Couple of things that we need to know, right? Object distance, did I go the wrong way? Yes, I did, right? There are two different kinds of curved mirrors, a convex mirror and a concave mirror, right? The convex mirror is an outward curve, right? So the mirror surface is on the outward side of the curve, assuming the object's here on the left, is a convex mirror. And a concave mirror, again, the object's here on the left, the mirror surface is on the inside of the curve. Okay, and we're gonna do ray diagrams. It'll simulate ray diagrams about where the image appears for each of these types of mirrors. Okay, we don't, because of our COVID world, right, drawing out the ray diagrams is going to be hard. Do you all have printers at home? So if I like sent you some, like,
Yeah, I have one.
so,
Kind of unreliable, but yeah.
right. So that's what I was a little afraid of, because I don't even have a printer at home. So like if I sent you a set of things to draw ray diagrams, I'm not 100% sure that you would be able to print them out to do it. So we'll see. All right, let's move on here.
Just like drawing like arrows or something.
Yeah,
You
But-
can probably just do it in Google Slides or something, like on the computer. Like,
maybe.
just send the image, just copy and paste the image and just draw arrows or something.
That's possible. We can try. We'll see.
Okay.
Yeah, yeah, that might be an idea. All right. When we do our ray diagrams, we are assuming that the object is so far away that, right, that the rays that are going into the mirror are effectively parallel to each other. That's an important idea, just because the angle of incidence and angle of reflection kind of stuff. All right, couple of vocab words to make sure that we understand. Vocab words, right? About images. There are two different kinds of images. There's a virtual image and a real image. Okay. A virtual image is the where the image does not, you can see, does not appear on paper because light does not actually pass through this point. So virtual images are images behind the mirror surface. All right, because the light's not actually behind the mirror, right? The light's actually in front of the mirror. A real image is just that. It can be, a real image can be formed, and I'm going to show you this, at least I'm going to try to, hopefully in a second. I have a little demonstration that I can show you a real image, but I'm hoping that I can set up the camera so you can see it. Real image appears in front of the mirror because the light's actually there. Okay. Other terms, a focal point is, as you can see, position where all the reflected lights all converge. It's called the focal point. The focal length then is the distance from the mirror surface to the focal length, or to the focal point. And the principal axis is the straight line that goes right through the center of the spherical mirror, right? So I'll show you a picture of all of those things in a second. All right, but these are our terms that we need to be aware of, all right? Because we're gonna use them a lot. Can I move on? Or is somebody copying these words down?
I'm good to move on.
Okay. All right, so here's our picture, right? Here's our curvature, and this is a concave mirror, right? So just covering some of those terms that we just termed. The focal point, if you notice all of the rays that go in here and they reflect back and they're all reflecting through the same point, that's the focal point. The center of curvature, which wasn't on our list, is the center of this. If we can imagine this little arc is the arc of a circle, that's the center of curvature is the center of that circle. And the focal point is half the distance, so it's half the radius of the circle. Is always that's where the focal point is. And a focal distance from the mirror to the focal point is always half the radius of the circle. What other things that were on there? Oh, the principal axis is this one line that goes straight into the center of the curve of the mirror. Okay. All right. So let's do the image thing. So I'm going to stop the share and I'm going to see if I can set up the camera and show you the real image. So here's my candle. So I'm going to use my candle where's my thing? Is my object is going to be the flame is going to be the object. Okay, the flame is the object. Here's our mirror. You can see it's curved, right? And if I hold it the right way, I don't know if you can tell, but there's a little bump in there, right? So if I use this side, the outside of the bump, this is a convex mirror. The inside of the curve is the concave mirror. So I'm going to use the concave mirror. And so the light goes into the concave mirror. It reflects back through the focal point, right? From all of the curve. It reflects, I blow it out by talking too much. It reflects back through the focal point and it makes an image, and I can focus that image on a screen. So this is going to be a real image. So I'm hoping I can do this in a way that you can see it. Okay. All right, so here's my thing. And I just have to play with, I don't know if you guys can see or not. I've had it working, there it is. How do I adjust my camera? Let me adjust the camera a little bit. All right, can you see I don't know how well there it is. Right, you see the light down there? Oops. See how the light on the screen? There, right? If I adjust the distances, I get that light on the screen there, here. That's a real image. And it's not really focused very well, but, and I'm sure you can't tell, and it kind of goes in and out of focus because I can't hold it perfectly still. But when I do get it focused, it turns out that the image is inverted. So the top of the flame is on the bottom of the image, and the bottom of the flame is on the top of the image, which I'm sure you can't see. But that's what we're talking about with a real image, right? The light is actually out here in front of the mirror. So that's a real image. A virtual image, if I turn my mirror around, so it's a convex thing, I can't do that because the image for a convex mirror appears over here on the back of the mirror side. So since there's no light here, I can't put the screen and get it to appear on the screen because there's no light back here. The light's all in front of the mirror. Okay, that's the idea of a real and a virtual image. Perfect timing, good place to stop. 11:56, the class is going to end. All right, guys. So have a good day, and I'll talk to you all tomorrow. We'll continue. All right.
See you,
Mr.
Shuki.
Shuket.
Have a good one, Mr. Shuket.
Bye-bye. I'm gonna turn the recording off.